There we go. Yeah, I don't know what happened there. I went to transition from the intro and I turned my mic on and like something crashed the whole thing. So that's not cool. We don't want that. Computers are the worst, man. Like, you'd think you could get them to cooperate, but you can't. So, where did we leave off last time? We were in domain 3. And we talked a lot about, we're starting to dig into these core services. You gotta focus, right? Focus. And we went through the compute services, right? So this is what we talked about last time. Our EC2, our Beanstalk, our Lambda. We're ready to move into the content and network delivery services section of AWS. And there are 6 different services that really make up the content and network delivery. That's and we're going to talk about each one, but Route 53, VPC, and Direct Connect, right? They're independent, but we'll talk about them together. Elastic Load Balancing, CloudFront, and API Gateway. And again, independent services, but we're going to talk about them together. So if you haven't been following along with what we're doing here, I have this document and I'm linking it into the chat, or you can do !GitHub and get that out of there. But this is it's a GitHub repository if you want to go poke around in all my other repos. But study resources and things that we've been discussing as we've gone through here. I'm kind of jumping around. I'm not doing these in order because, as I've explained previously, I have a bunch of notes and resources and things from when I did this exam a long time ago. Well, it wasn't that long ago, but getting these organized is really part of the goal here. So we're here in our domain 3 document, and we're going to come down here to our content and network delivery services section and start talking about so let me see here. What do I got on VPC and Direct Connect? All right, VPC and Direct Connect. So VPC stands for Virtual Private Cloud, if you didn't know that already. And this is a, so let's make some notes. VPC, Virtual Private Cloud. And this is a logically isolated section of the AWS cloud. I'm gonna make that a little bigger. Oh, that's too big. This is where, in your virtual private cloud, this is where you can launch your servers that we talked about in the EC2 section. And it's like your own little private slice of the cloud, right? So you have this virtual network that you can define and configure around whatever your business needs. So this can be, particular types of access or firewall rules or really whatever makes sense for your application. And you don't have to have a virtual network in AWS. You don't have to know anything about networking really at all to pass the Cloud Practitioner Exam, but you do need to understand what a virtual private cloud is, simply because it's one of the services. So a virtual private cloud can support IPv6 and IPv4 addresses, and those are just different standards that we have on the internet for the addresses that computers have on networks. So if you're not sure what IPv4 and IPv6 are and things. You're not going to see these kinds of questions on like anything in detail on the exam. They're just different standards that we have for the types of IP addresses that computers are going to have on their network. And you can configure, if you want to have this level of detail, address ranges, subnets, route tables, network gateways. Again, if you don't know what these things are, it's okay. I would encourage you to do some additional extracurricular reading so that you know what they are. But if you want to have areas that can't communicate or be reached from the public internet, then configuration of your virtual private cloud is how you make that happen. So let's think of an example. Let's say we have a web server that, of course, we want to have available and open to the public. And we can do that. And if you do have private subnets, you can use what's called network address translation, or NAT, for those private subnets. And there's multiple ways that you can, establish the connection to your data center and things like that. But the virtual cloud, they see everything in there, they see each other, and they can connect to each other. And the gateway is able to connect to multiple virtual clouds. They can all have private connections. So you understand here that you have a lot of different scenarios. You have a lot of different flexibility and things. We're not going to dig into like really a lot of networking here because that's not important to the exam and what you're trying to learn to be successful on the exam. But you should understand, that you have this ability. And then with Direct Connect, so let's talk about Direct Connect, because again, this is a different service, but Direct Connect is a service that basically makes it easy for you to establish a dedicated network connection from your data center that you might have on-prem, like your traditional data center, to AWS. So that you can configure things that are going to talk to each other. And, let's say you have a business application that uses application data stored within your data center, but the application itself is running on AWS. So it's ideal to have a high-speed connection between your data center and your AWS cloud resources, as opposed to sending it, through the internet, which is going to take longer. And that's what Direct Connect provides for you. And that's really all there is to it. There isn't a lot more that go into these two. All right, Route 53. Good stuff. So this is Amazon's DNS service. And if you don't know what DNS stands for, right, that's a domain naming service. And this is basically a directory. A DNS is a directory lookup that translates things like Amazon.com, right, to a particular IP address where Amazon's web servers live. It's the lookup, right? And so Amazon keeps their own DNS service, and it is basically spread out and hosted amongst 8 of the different locations inside of the global infrastructure. So at a high level, Route 53 is a domain name service. So, but it's a global service not a regional service. So any changes you make to resources that are listed in Amazon's DNS service are gonna be applied globally. It's highly available. Part of the reason why it's spread out amongst 8 different locations. And it allows you to create what we call a highly available service. And so what that means is global routing. So you can send people to the server closest to their physical location. So, based on where they're coming from, you can send them to the server that's going to respond the fastest, which honestly is better than sending them to a centralized server all the time based on nothing, right? Like they're in the United States, they're in the United Kingdom, they're in India. They would maybe all have to call home to your web server in the United States, which for some customers is going to be fast and for some customers it will be slower. But with Route 53, that global routing means that your customer in India is going to get routed to a server closer than a one in the United States. So it creates that highly available application service. What else? You know, a DNS service, like I said, if you're not familiar, just allows you to map domain names like Amazon.com to the specific addresses that are needed for identifying those IP addresses, right? Because no one is going to actually memorize an IP address for your business website. Any changes you make to Route 53 are applied globally. I think I said that. I don't know why I wrote it twice. Apparently it's really important. Right, so that's basically it. You know, that the example I gave you of different customers in different locations, that's basically the idea. It also means that, like, if your server goes down, like let's say you've got your server in US East and something happens, that US East data center, or let's say you deploy a bad configuration and then people aren't actually able to access that server, then you can configure Route 53 to have a failover so if one server is misconfigured or unavailable in the data center, you can route traffic to another location. So your uptime is not affected, right? Super handy. Okay. Elastic load balancing. We're going quick today because I figured these content delivery things, there's not a lot to go over them like there was with the computing side of things. All right, so we're gonna talk about elastic load balancing, which is a familiarly named service to the Elastic Beanstalk. And that kind of plays into that whole concept of elasticity and what the cloud can do, and its ability for infrastructure and supporting application growth, and how much it's being used at the time. So one aspect of that is how we actually route users to the correct infrastructure. And this is where elastic load balancing comes in. So what elastic load balancing does, in essence, is can distribute traffic across multiple targets. So basically what that means is if we have users that are coming to our web application and we have 2 different servers, it can choose the route, or it can choose to route the users between those 2 different servers based on the load. right? To keep one server from being overwhelmed, to make sure that the application is always going to work correctly. By default, will work with 2 EC2 servers. Servers or services, which we haven't talked about services yet. But in the AWS, we have the container service. Those are EC2 services. Or if you're running those Lambda containers, it supports let's see how we want to put this. Supports across spelling availability zones within a region. So for example, we want to have our customer website running across 3 different availability zones, and we want to have servers that exist in each availability zone, and then we leverage the elastic load balancing to distribute users to the right servers in one of those 3 availability zones. So that's good. 3 types of load balancers. All right, so let's see. Application load balancer. Let's just application, there's network load balancer, and there's classic. And I've been doing this for other things, and I'm sorry I didn't pull this up for the other one, so I guess we can go back. If you want to look at VPC settings, you can see all this stuff under network and content delivery down here. You can come in and look at your VPCs, which regions you're in, subnets you have, route tables you have, gateways you have. Here are all of those settings, and you can see that it can get quite technical depending on the level of network specificity that you want to use. Again, there's wizards for this. You don't really have to know a lot to make this work on a very simple level. There's a lot of kind of hand-holding and things on the part of the wizard. So if you aren't specialized or trained in any kind of network usage, I lost my word there, then you don't really have to understand too much here. Similarly, for most of these tools, they really do try to make it easy. In the Route 53 section, they talk about the different types of things that you can do here, and there's basically wizards and things to help. There's a bunch of things in here about availability monitoring so that you can look in real time about what's happening and how that traffic is being monitored. Again, traffic manager, you can come in here and set all of this up and use these services and kind of get a feel for how they work. I encourage that you do so. And then down here, we talked about direct connect. I don't know that we can actually set up, because usually you do it through the EC2 section. You can't actually get into see, it doesn't come up. You can't actually open the elastic load balancer, it's like not listed in here. You have to go into the EC2 section and do it in there. Oh, I've also been pulling up the, let's do that. Pricing and such. We're going to talk lots about pricing. And they talk about the 3 different types of load balancers in here. We can add this to our doc here. Guess I could really do this for all of them, put the links in there. Probably be easier, huh? All right, but an application load balancer, right, best suited for load balancing of HTTP and HTTPS traffic used in web applications. Delivery of modern application architectures, including microservices and containers, all good. Network load balancer, best suited for load balancing of TCP, UDP, oh that was weird, and TLS traffic where extreme network connectivity performance is required. So that's TCP, Transmission Control Protocol, UDP, User Datagram Protocol, and TLS, Transport Layer Security Traffic. So these are, like I said, where high performance network connectivity is required, making sure that it routes traffics to targets within your virtual private cloud. We could also say it is capable of handling millions of requests per second while maintaining ultra low latencies. Good stuff. And then your classic load balancer is just basic load balancing across multiple EC2 instances and operates at the request and the connection level. But as the title implies, it's some just basic stuff. Let me go back and put some nice links in here so that you have links to the documentation as well. For reading more good stuff. Let's do it like this. My allergies are driving me kind of crazy today. My nose is so itchy. It's like, hello, spring. It hasn't stopped raining in days. It's really bumming me out. All right. So as you pursue further, if you really get in more into cloud architecture and best practices and patterns and things like that, you start to really learn about, best approaches for using things like load balancers and network scaling and really how to leverage a lot of these things. This is, further out of the scope of the Cloud Practitioner Exam. So, you can read a lot about, which one do I use and what are some best practices and things like that. And if you do get into some of those more higher level certifications, then, of course, that's important information. All right, so we're gonna talk about CloudFront. Let's get the link. CloudFront is Amazon's content delivery network. So, two things that we're going to talk about in here. You know, CloudFront and API Gateway, they really work together. CloudFront is a service that leverages the edge locations within the 8 places of the US global infrastructure. And so it's a CDN. That's Content Delivery Network. Works in the 8 US infrastructure locations, and there are servers around the world. And if you're not familiar with what a content delivery network is, it is a service, let's put this up here, that allows you to securely deliver data, videos, applications, and APIs to your customers with low latency, high transfer speeds. Yeah. Sorry, the sinuses are driving me crazy. So you load all of your content up, servers around the world, and it enables your users to get that content from the server that's closest to them, which increases performance. Supports static and dynamic content, because most people that are familiar with content delivery networks, they think of them as only serving static content like images or videos or specific text. But with CloudFront, you can actually configure it to support dynamic content. Mention the 8 of the US global regions, includes several advanced security features. So you can protect your business from things like denial of service attacks, we'll talk more about security later. There's a couple of things that CloudFront, particularly helps with security, but we have a whole section on security. But that's basically it. It's a fairly developer-friendly environment. So it's, and it's integrated all within AWS, and so you don't have to do a lot to set this up and to make it work correctly. But it works seamlessly with, again, shielding you from things like just denial of service attacks. It works with the elastic load balancing, your EC2 instances, your Lambda code, your containers, like all of this stuff. I guess there's an important part in here, and I guess we'll talk about this again when we get to pricing, but if you use Amazon's S3 buckets, EC2, or elastic load balancing, you do not pay for any data transfer between those services and CloudFront. So that helps on some costs as well, and that might really be an important feature for you. All right, so we're also going to talk about API Gateway. Let's pull up the link. That is the wrong brace. Okay, API Gateway is a fully managed API management service. Now you might be like, what does that mean? It makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. So APIs basically work as like the front door for applications to access data or business logic or functionality from your backend services. And so using API Gateway means that you can create those APIs, you know, RESTful ones, WebSocket ones, if you're familiar with how APIs work, that enable real-time, you know, two-way communication between different applications. It does support containerized, holy crap. And serverless workloads, which we've talked a little bit about serverless code, as well as web applications. So good stuff there. Again, in all of the 8 US service areas, global presence, gives you things like monitoring and metrics on API calls, so you understand how your APIs are being used and be able to troubleshoot problems. Right, that's all important stuff. And I think that's it. Now, I didn't go over the scenarios for our computing section last time, and I kind of regretted doing that. I really think that I should go ahead and put those in. I really should have done it last time. So let's go ahead and do the scenarios for computing and the scenarios for content delivery. So let's go down here. Scenario review questions. Oh. All right, so we're gonna go through, like we usually do, 3 different kind of scenarios that will help you kind of understand how well you've absorbed the information. This would be the stuff that we talked about last time. So we're gonna talk about business A. And so let's see. Business A is in the process of moving multiple workloads to AWS. One of those is an application that will be leveraged for at least 5 more years. This is a core business application that the company will be leveraging for the foreseeable future. However, they're looking to be as cost efficient as possible for this, and they want ease of use. So the question here is, what computing options should be chosen for the application? So based on what you learned last time about things like EC2 and Lambda, what computing options would be chosen. Let's go ahead and lay out the next one so you can think about that. Okay, next we have Business B. They are looking to deploy a PHP web application to a virtual server. I don't know why I capitalized that. They do not have the experience managing EC2 instances on AWS. They need the ability to scale, and they do think that the application will be popular after launch. So our question is, what is the best compute option for Business B based on this criteria? All right, just a second. Actually, I think I want to change these. Sorry, I'm messing with the formatting. Oh. Okay. To the cloud for its data processing workloads. These workloads happened daily and can start or stop without a problem, so they're configured to handle that. The workload will be leveraged for at least 1 year. So our question is, What easy to purchase option would be the most cost efficient choice? Okay. Answers. What do we got? Well, in this first scenario here, let's see. All right, so they're in the process of moving their multiple workloads. They know that they're going to use this for at least the next 5 years. And that's some long-term planning, right? And when you can do long-term planning like that, then you get a pretty significant price break because you're committing. So of course it's going to be an EC2 and typing. I hoped standing today, because I have a standing desk. I really hoped standing today would mean that I could type better because I really don't sit a lot and work. But I think it's I don't know. So it's going to be an EC2 purchase option, all up front, reserved for 3 years, which is, you know, we didn't really dig too much into pricing in this section, but that is the best possible price break if you go look at the documentation. All right, scenario 2 for business B. So what's the best compute option based on the criteria? That's AWS Elastic Beanstalk. So they want to deploy their web application to a virtual server. They don't have experience managing EC2 instances. They want to scale. They think it's going to be popular. They don't know what they need. Set it up on EC2, put it in Beanstalk, let it do the managing, walk through the wizard. They don't have to know what they're doing. Beanstalk will take care of it for them. AWS wizards are going to put us all out of a job. All right, scenario 3. This company is transitioning to the cloud for their data processing workloads. The workloads happen daily. Really, the most cost-efficient choice here are spot instances. So if you remember back to what we looked at with the EC2 instances, then spot instances were our cheapest option. And so that's what we would want to go with. All right, so let's go through, these were our computing scenarios. We're now going to go through our network and content delivery scenarios. So we'll do it while it's fresh. So business A, they maintain 2 corporate data centers. Oof. They want their data centers, sorry, to work alongside AWS for specific workloads. They are wondering if there is a way to have a persistent connection to AWS. Well, we know that the answer is yes. All right, so the question is, what service from AWS would you recommend? And hopefully, because it's all fresh in your brain, you know that the answer is AWS Direct Connect, which is that service that allows you to connect your on-prem data center with your AWS resources. Yay, good job. Okay, scenario 2. Business B. All right, business B serves content through their site to users around the globe. They are looking to optimize performance to users around the world. They know they want to leverage a content delivery network. or CDN. So which service would enable optimized performance globally for their content? And since we just talked about this, I really hope that you remember the answer is Amazon CloudFront. See, these are easier to do when I do them right at the end, instead of like, I was gonna wait until I finished this document and then you would have forgot it. And I know I'm writing them in here, but the whole point is to remember. All right, business C. They have an internal application that runs on an EC2 server. Currently, there is downtime as demand is greater than capacity for the server. The company is trying to decide if they should use bigger servers or more servers. So which scaling approach would you recommend, and what services should they use? All right, so we didn't look at scaling approaches so much, but you can go into the Elastic load balancing documentation and see that they should use horizontal scaling. As their method. Okay. Do I have other questions I could put in here? I don't think I do. Okay. We went through all of this. Let's commit. So nothing bad happens to all this stuff we've typed in here. Let's check our formatting to make sure it doesn't look all jacked up. Okay, well, that's fine. Okay. Good, 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 good. Our document is becoming so worthwhile. Next, we're going to dig into the awesome world of file services. Super good stuff. And we're going to start with S3. And you've heard me talk about S3. And we can see in here, you know, that there's basically, well, there's 6 different services that fall under file storage. So S3, Glacier and Glacier Deep Archive, Block Store, File System, and Snowball. And so that's what we're going to cover in this section. We're going to talk about overall storage that's available on AWS, you know, how it's part of that ecosystem. But I think we're going to talk the most about S3 and its capabilities as a core service, because there are so many different aspects to S3, and you really need to understand how it works to be effective on AWS. So that's why we're going to start with S3. S3 stands for Simple Storage Service. Oh, I didn't link the documentation. Ruined already. All right, Simple Storage Service. This is an object storage service. And I realize you may not understand what that means, but it's an object storage service, and we're going to look at how this works, that offers scalability, data availability, security, and performance. So it doesn't matter. All sizes of industries can use it to store and protect any amount of data for a range of use cases, websites, mobile applications, backup and restore, enterprise, Internet of Things, big data. There's so many uses for S3. So object storage. S3 uses what are called buckets. So we store objects inside of buckets. And buckets is the unit of organization inside of S3. So you create a bucket, it has a bunch of settings, and then any file you can drop in there can have those settings apply to it. There are a bunch of different storage classes and different use cases. So let's get into the storage classes. All right, so like when we looked at EC2 and there were all of these different types of servers and stuff, S3 has a bunch of different types of storage defined for different use cases. So we're going to run through each one of these. So we have, under the general purpose, we have S3 standard. So this is, you know, just like it says on the label, standard storage. You're going to get high availability, high durability, performance object storage for frequently accessed data. You get, you know, pretty low latency, high throughput. Let's see, appropriate for a pretty wide variety of use cases. So cloud operations, dynamic websites, content distribution, mobile and gaming. So you can get all of the really pertinent details in the documentation, but that's really how it goes. Oh, sorry, hold on. I put this on a different sheet. Probably one of the most useful things, and I'm gonna add this up here. Just information about S3. So we're talking about the different storage classes for different uses. It stores data across multiple availability zones, enables URL access for files, which is super helpful sometimes. Offers configurable rules for your data lifecycle. So depending on how often you access data, or when you need to put it in storage and things like that. And then another really pertinent thing I wanted to make sure to talk about, it can serve as a static website host, which is kind of big for people. And these general purpose storage classes are also considered to be non-archival, which could be important depending on the needs of your business as well. So S3 standard it's the default storage class for frequently used data. Then we have the S3, whoops, I'm gonna, too many weird spaces here. Intelligent tiering. So intelligent tiering will move your data to the correct storage class based on usage. So this is honestly pretty awesome. So if you don't know which S3 type to use, you can optimize costs by moving data into this intelligent tiering access. And what it will do is try to optimize your costs by then arranging the data into the most cost-effective access tier without impacting your performance or your operational overhead. So that's pretty awesome. It has the same latency and high throughput standard of the standard. You do have a small monthly monitoring and auto tiering fee for intelligent tiering, but if you aren't sure, then this is a great option to choose. Then we have standard IA. Now this is an infrequent access. So S3 standard IA, which is infrequent access. This is for infrequently accessed data with the standard resilience. So basically what that means is if you have data, it's accessed less frequently, but when it is accessed, it still requires that rapid access that S3 provides, then this is the best option. So you still get that high durability, high throughput, low latency, but your gigabyte per gigabyte storage price and per gigabyte retrieval fee is lower, because the expectation is that you won't be dipping into this bucket nearly as much. All right, and the last one we have in this category is one zone, which is also IA or infrequent access. And this is for infrequently accessed data that is only stored in one availability zone. And really what this gets you is the same thing that like standard IA would get you for data that's used less frequently, but requires that same rapid access. But unlike all of our other S3 storage classes where you can store data in a minimum of 3 availability zones, this is only going to store data in a single availability zone and therefore costs 20% less than like standard IA. So one zone is ideal for customers who really need the lowest cost option for infrequently accessed data, and they really don't care about the availability and resilience. So things like secondary backup copies, of on-premise data, or easily recreatable data. So that's something to keep in mind is, you know, how often is it accessed and when do you need it? All right, so that's our general purpose classes. Next, we're gonna get into our archival classes. I don't have too many notes on this. Honestly, archival, storage, well, this is down in Glacier, honestly. So let's hold off for a second, because Glacier and Glacier Deep Archive are essentially what I'm going to be talking about. I want to make sure I cover everything else about S3. Let's see, lifecycle policies. So objects in a bucket can transition or expire based on your criteria. So you can have it set up to where, you know, data is created in a bucket in general purpose storage. After a certain period of time, it transitions into more infrequent access storage, or it just straight up expires and you don't need it anymore and you release it. So you can set up this criteria and what it means for your storage, so you don't have a bunch of manual processes to get in there and do that. Transitions can enable objects to move to another storage class based on time. And then expiration can delete objects based on age. And then these policies can also factor in versions of a specific object in the bucket. So if you're keeping versions of objects, you can actually set your policies to happen based on those specific versions. Okay, what else do we want to talk about before I get into Glacier? I think that's probably it. You know, I mentioned earlier that you can host a website on Amazon's S3. You can load objects up to the bucket and stuff like that. I don't know if that would be a useful demo on how S3 works. We can definitely go look at it in the console. So here we are under storage. There's our S3. I don't think I have any buckets set up currently. Oh, I do. Oh, yes, I do. So most of these are for reporting. So I've got a couple of things in here for reporting. I also have an Amazon Deep Lens camera, and there is an S3 bucket for the data that Deep Lens collects. And so you can actually come in here. Yeah, there's nothing in here right now. Let's pick something that has data in it. This is my billing usage bucket. So this is the bucket. These are objects inside of the bucket. You can see they're all CSV files. You can put whatever you want in here. I can click on these, I can upload things, I can create folders and organize the information inside of them. I can set up things like the properties that we talked about, logging, locking, events. I can set up permissions and access control lists. I can manage the bucket and create those lifecycle rules that we talked about. This is all very easy to use. Everything is exactly where you kind of expect it to be. You can search the data in here. So in this particular bucket, it's my billing usage reports. It generates those on CloudWatch and it dumps them into this bucket, and you can see that it's been going on a very long time. Each bucket can have kind of whatever it's got going on. I don't remember particularly what's in this one. Nothing. Oh, things from CloudTrail. I don't actually think there's anything in there. This is the bucket set up by the Elastic Beanstalk demo that I did the other day. It created this by default in case you had information coming in from Beanstalk, but I deleted the Beanstalk, and so I could delete this bucket as well. Oh, you do have to empty the bucket. Before you can delete it. I don't have permissions on my own account to delete this bucket. That's cool. I'll have to go look at that later. I like that. That's good stuff. All right, anyway, that's basically how it works. If you did want to play around with the whole, like hosting a website on S3, you can definitely do that. So you can create a bucket, you can configure it as a website host, you can upload the files that are going to go into your website, you can actually stick a URL on it or it'll give you one. So you can, in here when you're creating it, you can set it up for public access. There's a lot of different settings when it comes to like who can access your bucket. But it's kind of, there's a lot of different reasons why you might do that. I guess a lot of people like that. I personally think that there's better services for creating a website than using an S3 bucket, but I guess if you just needed like a quick, simple little HTML with some images or whatever, you could just throw something up there. All right, let's talk about Glacier. And so Glacier and Glacier Deep Archive are basically, I mean, they're still S3 tiers, but they're very specific for archival data and are kind of a separate storage class. So you'll find it on the same page as the S3 documentation, but I'll put it here. So Glacier is a secure, durable, low-cost storage option for data archiving. So if your business requires you to store data, maybe for compliance reasons for a certain amount of time or for reporting purposes or whatever, then you need to have some kind of data archiving solution for all of the things that you need to keep long term. You can reliably store any amount of data in Glacier at costs that are very cheap or cheaper than your traditional on-premise solutions. There are 3 different retrieval options. So if you do have something in Glacier and you decide that you need to pull it back out, there's ways that you can do that. So designed for or has configurable retrieval times when you need to get files out of storage. Can send files directly from an S3 bucket or through lifecycle rules in S3. So there's 2 different storage classes. There's Glacier and there's Glacier Deep Archive. So basically the difference is, Glacier is designed for archival data. You can have a 90-day minimum storage duration change. Can be retrieved in minutes or hours. You pay a retrieval fee. Cannot spell today to save my life. Retrieval fee per gigabyte. And I mean, very, very cost effective. Like I said, much cheaper than traditional on-prem. So over 5 times less expensive than standard S3. All right, so Glacier Deep Archive basically gives you, a pretty good idea of what it means right up front. So, low cost storage class for long-term retention and digital preservation of data that may be accessed once or twice in a year. So really designed for those customers that have like really long-term compliance requirements. So financial services, healthcare, public sectors, where you have data sets that are 7 to 10 years or longer to meet those regulatory compliance requirements. So what did I say? Financial services, healthcare, public sectors. Can also be used for disaster recovery, or backups in particular use cases. It's pretty cost effective, easy to manage alternative to, what most on-prem places use, which is like magnetic tape systems, whether you've got on-premise libraries or off-premise services. Other key things, 180-day minimum storage duration change. Can be retrieved in hours. Just like in Glacier, you pay a retrieval fee per gigabyte. And then the cost savings here is pretty extreme. Over 23 times less expensive than S3 standard. So that's pretty incredible. You can use the console to set up your Glacier. Data can be uploaded and retrieved, manually or programmatically. Again, you can create policies that allow you to move things to Glacier. When you're looking at you're loading and retrieving data, this is what you want to really, because if it's in Glacier, it can be retrieved in minutes if that should be something important to your business. Otherwise, it'll be hours. I just realized this window is cleared to off center. Sorry, that was bothering me. But there are just certain things that you can't, or that you have to think about when you're choosing these long-term archival storage things that'll be, pertinent to your business or your customer's business. So cool, literally cool, like a Glacier, right? All right, so that's basically it about S3. They have a nice performance chart and things in the documentation. So if you want to dig through that and take a look, I would advise that so that you get a little bit familiar with how S3 works and all the different types available and how they should be used. All right, so now we're going to talk about Elastic Block Store, which is separate. This is a separate service from S3. What the hell is that? Why is... I don't appreciate that, Amazon, at all. All right, so Elastic Block Store. Before we get, I think, too deep into Elastic Block Store, also called EBS, there's some different approaches that you can take for file storage on Amazon. So the first is that block storage, which is persistent. And that's what we're going to talk about is block store or Elastic Block Store. Then you have the Elastic File System, which is also what we're going to talk about in here, which is like a network file system designed for, those type of workloads. So you got to understand there's basically two different ones, and we're going to talk about kind of like what we did with S3, the differences between the two, so that you can really understand, what's the best decision. So Elastic Block Store is a high performance block storage designed for use with EC2. And actually, let me commit. I hate not saving often before I get too far into this. Okay. Oh, too far. Provides for both throughput and transaction intensive workloads at any scale. So this could be things like relational or non-relational databases, enterprise applications, containerized applications, big data analytics engines, file systems, media workflows, right? All of those kinds of things would be things that you could deploy to Amazon EBS. There are 4 different volume types depending on what you need. So what else do we get? We get redundancy within an availability zone. Allows you to take snapshots of its data in case of backups or recovery or whatever you might need. Offers encryption of its volumes. Yeah, okay, so multiple volume types. We're gonna have general purpose. And we looked at this a little bit when we talked about EC2 originally, because we talked about different types of storage and things like that. And we saw, you know, some of the different SSD volumes that were available to us when we brought up a server, but here's where we can talk about, you know, those more specifically. So provisioned IOPS SSDs. Throughput optimized hard disk drives and cold hard disk drives. So a general purpose SSD is really your, I mean, that's your default. It's a cost-effective type designed for general workloads. Almost nobody puts hard disks in anymore unless they really can't afford to, but SSD prices have come down pretty significantly, especially in the cloud, that you really don't have to choose a standard hard disk drive over an SSD. And of course, those solid state drives are going to perform much higher and do those critical IO intensive type things better. So honestly, they're the better choice. I really can't say, you know, until the future, but I can't imagine that we're going to continue to use physical hard disk drives for much longer. It just doesn't seem feasible. There are some, you know, specifics in the documentation as far as general provision versus the provisioned IOPS can get you for, you know, performance. Let's see. Your general provision backed by solid state drives, suitable for a broad range of transactional workloads, dev test environments, low latency interactive applications, right? So that's why it's your standard default. That's what it is. These provisioned IOPS ones are a little different. These are going to be high performance volume for low latency applications. So when you have things like intensive database or application workloads, you know, anything that would be throughput intensive, data warehouse workloads, things like HBase, Vertica, Cassandra. Yeah, that's what these are best for. You can get, it says 50 IOPS per gigabyte to a maximum of 64,000 IOPS and provide up to 1,000 megabytes per second of throughput and volume. So these are highly optimized. You pay more for them, obviously, but if this is the kind of workload that you're running, then this is what you should choose in order to get the best performance. All right, so that's in comparison. Those are our two SSD options. That's in comparison to our hard disk drives. So throughput optimized hard disk drives are designed for frequently accessed data where you know, you're still going to use a hard disk drive. I'm just never going to be able to advocate. But it does provide the lowest cost per gigabyte of all EBS volumes. So, no, actually, the cold HDDs is probably the lowest cost, but of all EBS volumes with ongoing workloads. Whereas your cold, these are less frequently accessed workloads. Right, but I mean, obviously wouldn't use these unless you just literally are not accessing your data very often at all. It seems like the cost would be negligent. I mean, you can look at the pricing. Cold hard disk drives are 0.025 gigabytes a month. Your throughput optimized are oh, thank you for the follow, Mr. Chris. I appreciate that. So yeah, these throughput optimized hard disk drives are going to be 0.045. So we're talking about fractions of a penny. 0.045 gigabytes a month, as compared to our general SSDs, which are going to come out at 10 cents a gigabyte a month, or our provisioned high performance at 0.125, so 12.5 cents per gigabyte per month. So you can go use those calculators that I talked about previously and that I have linked in the documentation. So if you want to play around with this a little bit and see, you know, hey, I've got so much storage and I need to determine, you know, like, how am I gonna store this, or what is it gonna cost? Like, that's essentially what that's for. All right, next we're going to talk about the elastic file system. So this is a little different where, you know, and I was talking about, we have two options, but really, you know, they're very different, because elastic block store, we're really talking about persistent block storage. We're talking about drives. Whereas with Amazon File System, this is an elastic file system typically for use with Linux-based workloads. So let me get our documentation. Elastic File System, or EFS. All right, so this is a fully managed NFS file system. And so, again, primarily designed for Linux-based workloads. I cannot spell today. It's like my typing fingers are broken. Supports up to a petabyte scale. And I know that seems like a ridiculous amount. But we are starting to kind of encroach into that territory where petabytes are what we need. Stores data across multiple availability zones. And then we have two different storage classes. We have standard and infrequent access, which by now, hopefully it's like, you you know, Amazon does reuse a lot of terminology and things. And yeah, things like, you know, standard and infrequent. And so I think the last thing I need to add in here is it provides configurable lifecycle data rules. And so essentially, you get that same durability, petabytes of data, multiple availability zones. You get all that durability by default. Our data lifecycle rules means that you can transition between our two different storage classes. So the standard means that you can just store data, right? It's the general default option for file storage. And then infrequent access means that you have a cost optimization for files accessed less frequently. And you can set up the lifecycle management for your file system and choose basically like an age off policy. So you can go in there and say, well, if it hasn't been used in 30 days, move it from standard to infrequent, or 60 days or 90 days or whatever makes sense for your business. And it will just move those with those policies enabled from the standard storage to the infrequent access storage. This has a huge cost savings, something around 90% cost difference between standard and infrequent access. So of course, it's definitely something that you want to take advantage of. All right. What else? I think we're going to talk about Snowball. And then this is the last piece. It's actually Snowball and Snowmobile. You gotta love Amazon and the funny things that they name their components. Snowball, Snowball Edge, and Snowmobile, honestly, are all related services. So Snowball is a service to physically migrate petabytes scale data to AWS. So this is one of those tools that you use when you are migrating your on-prem data center and all of the, physical data that you have been managing, and you want to move it to AWS, even if that means that you're moving it to something like what we talked about with Glacier, where you just need it for long-term archival storage. Snowball is going to be the service that lets you migrate all of that data. There's the whole AWS Snow family, which are physical devices. I mean, we're talking about like actual devices that allow you to move your data. So they are both block storage and S3 compatible. You get 40 virtual CPUs and are suited for local storage and large-scale data transfer. You can get the Snowball Edge, which is a compute optimized device that provides 52 virtual CPUs, block and object storage, and optional GPU. So if you're doing like advanced machine learning or full motion video analysis in disconnected environments, this would be the kind of device that you would use. So you can use these devices for data collection, machine learning, processing, storage in environments that have intermittent connectivity. So like maybe in manufacturing, industrial situations, transportation, extremely remote locations for like maybe military or maritime operations. And then you ship them back to AWS. And then they can be rack mounted and clustered together to build large temporary installations. It's pretty incredible. So Snowmobile is a service to physically migrate exabyte scale data. Now you can just imagine the kind of operations that you're performing if we're actually talking about exabytes. But it is essentially the same type of service. But it definitely isn't the kind of situation that applies to most businesses. But if you need to move extremely large amounts, I mean, we can't even, people have a hard time visualizing, you know, it's almost like money. You think about billionaires, right? Like large amounts of money and like what that would physically look like. And it's really difficult to think about, all right, I have a gigabyte versus a terabyte versus a petabyte versus an exabyte. I'm sure you can find some lovely visualizations online to help you with this, but that is an extremely large amount of data. So you can transfer up to 100 petabytes per snowmobile. And again, we're talking about physical objects. It is the snowmobile, it sounds funny talking about it, is a 45-foot long, ruggedized shipping container. Maybe that helps you put the amount of data into scale that we're literally talking about like a semi-truck full of data. It's pulled by a semi-truck. So you can move your massive volumes of data into the cloud, video libraries, image repositories, complete data center migrations, all transferring data with your snowmobiles. Oh gosh, you would think plural snowmobiles, but this is the kind of service where, you know, you would have an initial assessment, then they would determine, you know, you have, all right, you're qualified. The snowmobile would be transported to your data center. It would come with AWS personnel that would configure it so it can be accessed as a network storage target. And then the AWS personnel would stay with your team to, you know, connect like a high-speed network switch so that you can start high-speed data transfer. And then once your data is loaded, the snowmobile is driven back to AWS or it's imported into S3. So multiple layers of security to help protect your data, GPS tracking, alarm monitoring, video surveillance, right? All of this is in the documentation. Again, a pretty highly specialized service that's really only for certain types of clients. But the Snowball and the Snowmobile are both physical devices delivered by AWS. In the case of the Snowball, you would receive the device, you would connect it to your network, upload your data, the device is returned by a regular like local carrier like UPS or something. when AWS receives the device, they load your data in S3. So it really depends on what you need in terms of data, but we're talking about moving, again, petabytes and exabytes worth of data, which is pretty significant. All right, so we've reached the end of our section here. So I'm going to commit before I jump into the questions section, the scenarios. This document's starting to get quite large. This is the, I'm just gonna keep linking it in the chat here for those of you who are hanging out with me. If you're wanting to grab anything that I just committed. And again, I've been working on this for quite some time. I think this is part 4 now. So you can go back through the highlights on Twitch, or I'm also uploading these to my YouTube channel, and you can watch the previous ones if you want to get caught up with what I've been doing. But we're going to come down to our scenario review questions, and we're going to set up a section here for doing our file storage services scenarios. All right, so the first one we have, push this up. They're always business A, business B, like across scenarios, the businesses aren't related, but they always present them this way. On the exam, sometimes they will use names like Tony works for XYZ company. I honestly find that distracting. I prefer the more generic business names, but it's personal preference. Business A launched a site that offers daily tutorials for developers. They use S3 to store the assets needed per tutorial. These assets, I cannot spell today to save my life, are very popular. Within the week, the tutorial is launched. After this initial week, these assets are rarely accessed. So our question is, how can business A reduce their S3 costs while maintaining durability? I'm gonna lay the next ones out and then we'll talk about the answers. So scenario 2, business B is a social networking company, and they are moving to AWS. They have 2 petabytes of user-generated content that they need to migrate. They are trying to determine if there is a faster way to move the data than uploading over the internet. So, would there be an approach you would recommend? Is our question. And then our last scenario, business C, is a company that produces a messaging app. They are looking for a shared file system between 8 different Linux EC2 instances. The file system would need to support roughly 1 petabyte of data. What approach would you recommend? All right, so with these kinds of scenario questions, it's always good to think about, what did we learn in the section? What are our options? And really, these are the kinds of questions that you see on the exam, but usually they're multiple choice, so you have some different options that you can review. But in this case, the business that launched the site that offers daily tutorials, they know that, they put that data in S3 within that week. It's very popular, but after that initial week, then the data is rarely accessed. And so in order to reduce their costs, the answer would be to set up an S3 lifecycle rule with, so starting with that, that standard class, but moving into that IA storage class that would allow them to reduce their costs over a period of time. So they load the data into S3 standard. Over that period of time, that lifecycle rule would move it into that lower availability, which means they would pay less for that storage. They would still be able to access it. What we learned about, let's scroll up, standard versus IA, right? So they'd still get that standard resilience, that high durability, the availability, the performance object storage, but it's for infrequently accessed data. So we would pay less over time. So that would be our best option there. All right, for business B, our social networking company moving to AWS, they have 2 petabytes of user-generated content they need to migrate. Is there a faster way to move that data than just uploading it over the internet? And we just talked about AWS Snowball, which they would be a great candidate for that kind of service. So again, AWS ships you an actual physical device of storage. You plug it into your data center, you transfer your data, you put it back in the box, you ship it back to AWS, they hook it up and put it in S3 for you. And so it's a lot easier and cheaper than trying to upload that data over the internet, and certainly faster. And then finally, business C. So we have our messaging app. We're looking for a shared file system between 8 different Linux EC2 instances that supports up to 1 petabyte of data. And that's that elastic file system that we talked about that perfectly meets those requirements, is specifically for Linux environments and would definitely support 1 petabyte of data. So hopefully, at this point, you understand a little bit more about what we're doing with all of these different services. And we talked about EC2, and we've really dug into all of these different compute services. We got into content and network delivery today. We talked about file storage services today. We're going to continue with these ones that I've lined out down here. So our last 2 that we're going to tackle are database services and then app integration services. And then that will complete, I think, what we're doing here in domain 3. Let's see, they also talk about identify core AWS services and then resources for technology support. I probably have something in my sheet about, management and government services, governance services, sorry. Which is, technology support, monitoring, all that stuff. So we'll talk about that in domain 3 too, but that will pretty much flesh out, what we've been doing. And so then we can start getting into, in this primary section, we still have a lot about security and compliance because I jumped over that. I honestly feel like, these are the order of the domains that are lined out in the exam, but if you don't understand these core services that are outlined here in the technology section, then it really doesn't make any sense to talk about security and compliance first. So we'll come back to security and compliance. We've talked a little bit about pricing and things and billing and how to look at those resources, but that'll be the last stop for covering what's on the exam. Again, I try to approach this with the idea that you have no idea what I'm talking about when it comes to AWS, that maybe you're not familiar with or have used these services before. And so I appreciate you hanging out, even if this is maybe some review for you. But the end goal is to, get that certified cloud practitioner, that CLF CO1 certification, so that you can enhance your resume and your cloud skills and then start to work on some of those more professional level certifications. That really is the goal. So that's going to make an end for me here. I try to keep these typically around 2 hours just for attention span purposes. And because, I can only talk for so long before I'm just going to sound all croaky and weird. So I appreciate those of you who came, hung out. If you do have any questions, you're welcome to join my Discord, which you'll find down in the Twitch page. Questions are also welcome to be posted on the YouTube videos where I'm uploading these as well. Happy to take any kinds of questions or point you towards any further resources while you're on your cloud learning journey. And then, we'll continue. I think this was part 4, so we'll continue with part 5, hopefully later this week, finishing off our domain 3 section. All right, well, I hope you guys have a great rest of your day. Enjoy, be safe, and be well.